Now that we've familiarized ourselves with the normal distribution, let's discuss one of the most common parametric tests that we might use to compare two sets of data, such as our samples of left-handed and right-handed MLB batters. That would be the t-test. The t-test, like many statistical tests, aims at accepting or rejecting a null hypothesis. A null hypothesis is generally a statement that we're trying to disprove by running our test. For example, that two samples came from the same population. This might mean that left-handed and right-handed batters show no real difference in their batting average, or that a certain sample is drawn from a particular probability distribution. For example, if we had a sample of 20 heights and weights of arbitrary baseball players, we might want to test how likely it is that those 20 people are drawn from the known MLB player population. A hypothesis test such as the t-test is usually specified in terms of a test statistic. The test statistic reduces your dataset to one number that helps to accept or reject the null hypothesis. When performing a t-test, we compute a test statistic called t. Depending on the value of the test statistic, t, we can determine whether or not our null hypothesis is true. In the case of a one-sample t-test, our null hypothesis would be that the population mean, mu, is equal to our sample mean, mu naught. In the two-sample case, which we'll be more concerned about for the purposes of our example, the null hypothesis would be that our two population means, mu naught and mu1, are equal.